So first we have to work out the earliest time. For the first box, it's simple, it's just 0 and 0 because it's just the start of the whole process. Then for A, the value of it is 3, which means that has to be 3. The earliest time goes into the top box. For this one it's 6, so 6 goes into that box. Then for here, it will be 6 plus 4, which means this will be 10. For C, it will be 3 plus 5, which is 8. And then these dotted lines here are just dummies, so they don't actually contribute to the time of anything. So then for this box here, it would be 10 plus 2, which is 12. And for here, you've got 2 lines going into it. You've got 8 plus 6, which is 14, and you've got 10 plus 7, which is 17. You have to pick the highest number, which means 17 goes into here. And then 17 plus 4 equals 21, and 12 plus 5 equals 17, and 21's higher, so 21 will go into the box. Then you have to work out the latest time. The latest time goes into the bottom box, so this one will obviously be 21. So you do 21 minus 4, and that gives you 17. 21 minus 5, that gives you 16. And for this box, 16 minus 2 gives you 14, but 17 minus 7 it gives you 10. You have to pick the lowest value, which means 10 goes into this box. Here, you'll do 17 minus 6, which gives you 11. And then 11 minus 5, which gives you 6. For this last box, it will be 10 minus 4, and that gives you 6. Then for part B, it asks you to state critical activities. A critical activity is an activity which has to be done before all the other activities, so they have to be done. So the way to work it out is, basically, you have to see, if it has no float, then it's a critical activity. It has a certain time it has to be done in. So A can be done in 6 days, but it only takes 3 days, so it's not critical, whereas B, it has to be done in 6 days and it takes 6 days. So this is a critical activity. Also, D is a critical activity because it has to be done in 10 days and it's got 10 days to be done, and it relies on B, so 6 plus 4 gives you 10. So the next critical activity would be E because, well, similar reasons. It takes 7 days, and considering it has to be done after D, which takes 10 days, it will go here. And then finally it will be I. 17 plus 21 gives you 17 plus 4 gives you 21, and that's the next critical activity. So your critical activities are B, D, E, and I. Next will be part D, which is where you work out the lower bound for the number of workers needed to complete the project in minimum time. For this it's easy. You literally add all the numbers in the brackets and then divide it by this time here. So in this case, if you add all this up, it would equal to 42, and that number is 21, and if you do that, you find you get 2. This means you need 2 workers to do the activity.
Okay, basically this is a Gantt or a cascade chart, and it's just another way of showing how these times, basically that thing there is the same as that, and then
these are our critical.
The fact that there's a float there, the way you work out a float is the bottom right minus the top left minus the time taken. So in this case that equals 3, because 6 minus 0 minus 3 equals 3. So then these little dotted lines here, they show the floats. And an important thing to note is that the critical path which you draw along the top has a sum. The sum of the floats equals 0. There's no float time. So if you delay anything, it delays the whole project, and that's why it's called the critical path. And then basically, so A goes there because it doesn't depend on anything, and C depends on A, so it can't start until 3. But then you've also got these floats, so if that goes there, then that can go there, and it doesn't actually delay the project, because then G as well has that. There's not actually going to be any delay. and then basically you've got G, which depends on C, so that starts there. Then you've got this little float here as well, so if you need you can move it along. And then you've got F, which depends on D and A, so that can't start until 10 because that's when D starts. And then A, because it's got this dummy here, it shows that you have to do that. And actually that's for E. Okay, no, yeah. But then you've got this little float here anyway, so it doesn't have to start on beginning of day 11 because you've got this float time left. And then H starts there. And again, you've got this little float, it's 21 minus 12 minus 5, and then you get this float, and it doesn't actually have to be finished until the last day, and then it still won't delay the project, because as you can see, nothing actually depends on it, because that's the end of the route, it's the end of the path. And so that's how to work out the float there. And then that's just showing how that links to that, because like these two are linked. And then the critical activity, the workers thing, is the total sum divided by the critical path. And basically what that's saying is if you can draw a thing called networking or planning or something, and you basically, if you imagine, if you move that up there, and then you move that up there, you move that along there, and that went up there, and that went up there, you could actually get it done by 2 workers because it fits on 2 lines. Like each little line represents the workers that it would take, and that one's showing that you can do it with just 2 workers. And then, yeah, so it could be done by 2 workers. And the last part is which activities are happening at 1 PM on day 8. Basically what that means is day 8 is there, but that's showing the end of day 8, so 1 PM would be here. So which activities have to be happening? Well, it's D and C. And then 1 PM on day 15, again it's there, but it's here. And that can move there, so none of them actually have to be happening, except obviously the critical one, which is E. So that's how you do that one. And that is showing how Gantt cascade charts work and how they link to everything else.